So before we talk about our last reaction, I want to do an example, and the example is just to show you how easy these questions are going to be. And then this example is going to say what amino acid would be formed in the N-phthalimidomalonic ester synthesis when the following alkyl halides are used in the third step. So this is the alkyl halide that we mentioned in the previous video, and we said that anytime we use the malonic ester synthesis that we are going to end up with an amino acid. So I can at least draw the amino acid structure, and the amino acid structure is going to look like this every single time when I make it. There's going to be no difference there, but that's kind of the starting product. This is, keep in mind, trace acid. So excess ammonia, trace acid. When we go through this mechanism route, you'll see that this will end up being protonated on the carboxylic acid end. But here we go. This is the starting place that I should do every time I work with these types of problems. And this alkyl bromide will tell me what group will go onto the amino acid. And this is the group that gets attached to the carbon of the alpha carbon. And the attachment happens where the bromine is at. So this is where the attachment is going to go on. And this is a CH2, CH, CH3, and CH3. So there's the amino acid that I will make. It's as easy as that. Now the problem is that I have to go through and try to figure out what amino acid did I just make here. And this is a isobutyl group. And if you go back and you remember your isobutyl group, the isobutyl group is called leucine. And the three-letter abbreviation is LEU, and the one-letter abbreviation is L. So that's as simple as these questions will be. You know, here's the alkyl bromide. You're reacting it with the malonic ester synthesis. What kind of amino acid is going to happen? So let's take a look at B and just kind of see what happens here. Same deal. We start off, we know we're going to end up with a COOH, and we know here's the alpha carbon, and we know here's a protonated amine, and then off of this carbon, well, we see an alkyl group. What kind of alkyl group? Well, the alkyl group is right here. So this is the site of attachment because that's where bromine is at. So CH2, CH2, S, and CH3. So if I go through and take a look and find the amino acid, but I shouldn't have to find it, I should know these structures by heart. This is methionine, and methionine is MET, and the one-letter abbreviation is M. So there's an example of the malonic ester types of questions that you will see. So there's the third reaction that we mentioned. We're going to look at a fourth reaction, and the fourth reaction is called the Strecker synthesis. So the Strecker reaction. This is something that we've seen before. We actually saw this in the carbonyl lectures as well. So go back and take a look at the carbonyls, take a look at this mechanism, take a look at the curvy arrows, but Strecker is really no different than any of the others. In the Stryker synthesis, what we have is an aldehyde. So we start off with an aldehyde, a C double bond OH, with an R group. Any random alkyl group could work. And we react this with a little bit of ammonia, NH3. And what happens is that we form an amine. So all of these reactions and these terms are coming back from last semester, and the amine is a C double bond NH. I kind of drew that up a little high, didn't I? So let me draw it down here. So this is a amine formation, and after the amine, we then will bring in a nitrile group, a C triple bond N with a little bit of acid, and what we end up with now is a R, CH with an NH3 group here, and a C triple bond N. And then finally, in the last step, we will then add acid and water, and we will end up with a C double bond OOH, a CH group here, an NH3 plus here, and a R group that's going to be out here to the side. So another way to make an amino acid, it just uses a couple of different reagents and a different starting product. So go back and take a look at carbonyl type 2 reactions. In carbonyl type 2 reactions, we looked at aldehydes and ketone reactions. This is where you will find the Strecker. So we're starting with the aldehyde. We add ammonia to make an amine. We then bring into the picture a nitrile group, and if you look, the C has kind of broken down to an NH3 group. The C double bond N has broken to a C NH3 group. A C triple bond N has been brought in now. Acid and water basically converts everything over to a carboxylic acid on the nitrile end. And whatever R group we start with the aldehyde, that determines the amino acid that I'm going to end up with. So I pick the aldehyde that I want to make an amino acid of. So if I want to make alanine, again, that's a CH3 group. I want to make sure that the CH3 group is here. If I want to make methionine, well, if I go up and take a look, methionine was a CH2, CH2S, and a CH3 group. So I want to make sure that that group is here for the R position, because that is what will carry over through the entire reaction and give me the ending amino acid that I'm after. So that's the Strecker synthesis. It's as easy as basically the Malonic ester to kind of figure out what amino acid that you're going to end up with. So take a look at the textbook, read that portion of the chapter, go back and review type 2 carbonyls. You'll probably see Strecker and the outline detailed mechanism a little bit better in that chapter. Go back and take a look at our older videos for type 2 carbonyls. You'll probably find Strecker in there as well. So all of this is a review. I'm not spending a lot of time on it for a reason. That's because I don't want to waste more of your time. But these are 4 reactions now that we can make an amino acid. We've got the Strecker, we've got the Malonic ester, we've got the HVZ, and we've got the reductive amination. So that's it of the reactions. There's no more. Now we go back to structure again, and we're going to take a look at structures of amino acids and what happens when they hook up and what happens as far as primary, secondary, tertiary, and quaternary structures are concerned. So we're going to kind of tilt and pivot a little bit, and we're going to go toward more of a structure representation lecture now of amino acids than reactions. So many of you, all of the hard work is now done. No more reactions, no more mechanisms, no more predicting products. It's now back to the basics.